Hello friends, welcome to my channel. Today I am going to start a last topic of chapter number 2, Polynomial of standard 10 maths. Our topic is division algorithm for polynomials. So it is look like a traditional division, right? So we start with the example number 6. Divide 2x square plus 3x plus 1 by x plus 2 and verify. So I told you that it is look like a traditional division, right? So I am going to divide it. Okay. So here we observe a leftmost term of the dividend as well as leftmost term of divisor, right? So here 2x square is the leftmost term of the dividend and here x is the leftmost term of divisor, right? So now 2x square is divided by x. So how you got a 2x square? By multiplying x. Okay. So now if you multiply x with 2x, you got 2x square, right? So here x is divided by 2x, you got 2x square, right? Now here is not a single term x, here 2 is also there. Okay. So you have to divide a 2 with 2x, so you got 4x. Here plus and here plus, so plus 4x is there. Now after you got this term, you subtract this term from this dividend, right? So how you subtract it? Just nothing, change the sign. Okay, here plus, so you got minus, here also plus, so you got minus. Now this 2x square and this 2x square got cancelled, right? Now here plus 3x and minus 4x. So minus plus a different sign. So 4 minus 3, you got 1 and x. So you got minus x because bigger digit is 4. That's why. Now this is shifted down plus 1, right? So you got x plus minus x plus 1, right? Now again divide it, but remember this sign is copy here directly, right? Like this. Here is minus, so without failing just put minus here. If here plus, then you can put plus here, right? Now you multiply x with 1, so you got x here, right? So now x multiplied by 1, so you got x. 2 is also multiplied with minus 1, so minus x and minus 1, so minus x minus 2. Okay. Now change the sign, right, and cancel x. Okay, this x got cancelled and here plus 2 and plus 1, so you got plus 3, right? So this is here you complete your division, right? So like a traditional division, this is your dividend, this is your divisor as I explained before, right? This is your quotient and this is your remainder, right? So it is like a dividend is equal to divisor multiplied by quotient plus remainder. That's you know very well. It is from chapter number 1, Euclid division lemma. You can also know that. Okay. So it is look like this: 2x square plus 3x plus 1 is equal to x plus 2 multiplied by 2x minus 1 plus 3. It is verified by you. Okay. Just if you multiply x plus 2 with 2x minus 1, okay, and add 3 to that term, then you got this number, right? 2x square plus 3x plus 1, this polynomial. So you can verify yourself. Okay, this is the verification method. Clear? Try yourself. Example number 7. This is nothing but just you divide like a previous example, okay, which I give you. Example number 6. Okay, so this is example number 7. Divisor is nothing but you just rearrange the divisor, so you got the answer, right? Example number 8. Here you have to rearrange dividend and divisor both, right? And these are the exercise 2.3, which you can also try yourself. If you find any difficulty, you can comment on the comment section of my video. I will give you the answer, right? Now another type of example is example number 9. Now you have zeros, okay? Find the whole zeros of 2x raised to 4 minus 3x cube minus 3x square plus 6x minus 2. If you know that 2 of its 0 are root 2 and minus root 2. So friends, here degree is 4. So it may happen the zeros are up to 4, right? That's you know from the zeros of the polynomial, right? So here 4 zeros are possible, but we have only 2 zeros. So what now we do? We are find the polynomial from using these 2 zeros, okay? So since 2 zeros are root 2 and minus root 2, so you can say that x minus root 2 and x plus root 2. So by multiplying this both, you got x square minus 2 is the factor of given polynomial, because it is the zeros of that polynomial. So you can say that the polynomial which come from these 2 zeros, it is always factor of this polynomial, right? So now we divide given polynomial by x square minus 2. So after that we got a quotient which are also a factor of this polynomial, right? So now start dividing. Here I put a 0x. Why? Just for the reference, okay? So you don't get some confusion. That's why I putting the 0. This is nothing but a 0x. So if you multiply any value with the 0, you got 0. So at the end of the day, you got x square minus 2. This is nothing but a simple 0x is for the reference, right? Now divide it. So 2x square, okay, with the x square, so you got x raised to 4, right? Now also minus 2 divided by 2x square, you got 4x square. Here 0x is there, so you can directly put here, right? Nothing but you just, this value is 0, because if you multiply any value with the 0, you got 0, that's why. Now change the sign, right? And 2x raised to 4 and 2x raised to 4 get cancelled, right? Here minus 3x cube as it is, right? Here 4 minus 3, so you got x square plus x square, right? I told you before, this sign is copy here, right? So first you down the 6x, right? This sign is copied here, right? Now multiply 3x with this divisor, so you got 3x cube, here 6x and 0 as it is, right? I putting 0 for the reference only. If you comfortable with this, you can no need to put the 0x square, right? Change the sign. 3x cube got cancel, right? X square as it is. Now 6x get cancel, and this minus 2 is here, so you got n x square minus 2, right? Now here is the plus sign, so you here put the plus sign, okay? Now x square is here and here also x square, so just multiply with the 1, so you got x square plus 0x minus 2, right? Change the sign, cancel it, okay? So you got 0 remainder, right? So this is the factor of this polynomial, right? Now this is your quotient, right? Now if you factorize this and find the zeros of this polynomial, then you got another 2 zeros, right? So let's try to find it. So I just putting here, so 2x square minus 3x plus 1, I am trying to find the zeros of this polynomial, right? So 2x square minus 2x minus 1, splitting the middle term, right? So 2x and minus 1 common, here 2x and 2x, and here minus 1 minus 1, right? At the end you got x minus 1, 2x minus 1. So zeros are x, you want to find the zeros, okay? So zeros are x is equal to 1 and x is equal to 1 by 2. So all the 4 zeros are now root 2, minus root 2, 1 and 1 half, okay, or 1 by 2. So this is the method to find the another 2 zeros or another number of zeros when 2 zeros are given, right? Here you have only 2 zeros, minus root 2 and minus root 2, and you find another 2, right? Now exercise 2.3, it is look like same, okay? You have another root under root 5 upon 3 and minus under root 5 upon 3. So just nothing, that these are the 2 zeros, okay? So find the polynomial from these 2 zeros and divide this polynomial by that resultant polynomial, right? Let's see that. So here 2 zeros. So by using this 2 zero, you got 3x square minus 5. Now you divide this polynomial 3x raised to 4 plus 6x cube minus 2x square minus 10x minus 5 by 3x2 minus 5, and result you got the quotient as a polynomial, and try to find that zeros of that polynomial. So you found another 2 zeros, right? It is try yourself. Now example number 9. Check whether the first polynomial is the factor of the second polynomial by dividing the second polynomial by first polynomial. So friends, if you know that what is the factor of simple 8 number, okay? So 2 and 4, okay, these are the factors, okay? 8 is also factor and 1 is also factor of 8, right? So how can you say if you divide that number, okay, 8 by that number, you got always remainder 0, okay? So here also a simple division is there, okay? So if the first polynomial is the factor of second polynomial, then division will, remainder of the division is always 0. Let's see that. Here is the 2 polynomial, t square minus 3, 2t raised to 4 plus 3t cube minus 2t square minus 9t minus 12, right? So now try to divide it. Simple, it is a simple division method which you see previously, right? So 2t square, okay, here 2t raised to 4, okay, so you divide it by t square, so you got t square, 2 is there, so 2t square multiplied by t square, you got 2t raised to 4, right? 3 is also there, so minus 3 plus 2, so 3 2s are 6, and minus sign is there, okay, and t square as it is. Here you can put a 0 also for the reference, right? Change the sign, right? 2t raised to 4 is got cancel, so you got 3t cube and plus 4t square. Now minus 90 is carry forward to the next, okay? Now this sign will be copied here, so plus, right? Now here t cube and here t square, so multiply by t, right? And 3 is there, so 3t, so 3t cube. Now this 3 is multiply with the 3, so plus minus minus, okay, minus 90, right? And you can put the 0 here for the reference, okay, and change the sign. 3t cube get cancelled, 90 get cancelled, so you got 4t square. Again minus 12 will be get down, right? Here 4t square minus 12, right? So here you multiply just 4, right? So you got 4t square, 0t as it is, and minus 12. So here you got a remainder 0. So you can say that this is the factor of this polynomial. So the first polynomial is the factor of second polynomial. So here dividing 2t raised to 4 plus 3t cube minus 2t square minus 9t minus 12 by t square minus 3. So remainder is 0. So first polynomial is a factor of second polynomial. Okay. So try yourself. Okay. Just dividing these polynomials. If you got the remainder 0, then it is the factor, and if you don't get the remainder 0 or you got the remainder non-zero, then it is not factor, right? Now next topic is on dividing x cube minus 3x square plus x plus 2 by a polynomial g of x. The quotient and remainder were x minus 2 and minus 2x plus 4 respectively. Find the g of x. Okay, so this is a simple, we know that a dividend is equal to divisor multiplied by quotient plus remainder. That's you know from the chapter number 1, right? Now dividend is your p of x, divisor is your g of x, quotient is q of x, and remainder is r of x. So you want to find the divisor, right? Because you want to find the g of x. Okay, so now if from this equation you can say that g of x is equal to a p of x minus r of x upon q of x, because just nothing, I just rearrange this equation. Okay, so I got this equation. Now putting the value of px, rx and gx, because you have this is your px, this is your qx and this is your rx, right? So putting the value, so look, px is equal to this polynomial, rx is equal to is given, okay, minus 2x plus 4, and this is x minus 2. Now simplify it. Okay, so you got this. So at the end you got x cube minus 3x square plus 3x minus 2 and upon x minus 2. So if you divide this, okay, and you find the quotient, this is your g of x, right? So now try to divide it. So divide first with the x square, so multiply with the x square. So you got x cube minus 2x square, right? Change the sign, x cube get cancel, and at the end you got minus x square, 3x come to down, okay, a same sign minus, so that's why here minus, multiply by x, because if you multiply with x you got x square, multiply 2 minus minus plus, so plus 2x, right? Change the sign, okay, x square get cancel, here you got minus x and minus 2 down, okay, multiply with the 1, okay, so you got x minus 2, so remainder is 0, right? So this is your g of x. Okay, this is your g of x. So by that, just nothing, you have if you have a px, qx and rx, you can easily find the g of x. If you have these two, you can also find this, okay, by just swapping the or rearranging this equation, right? So try yourself. Just nothing, want to say that give the example of polynomial p of x, g of x, q of x and r of x which satisfied the division algorithm. So it may happen that in different books you got a different solution. Okay, here what happened, in first you said that degree of p of x and degree of q of x are same. Okay, so degree of p of x, you know what is the degree, a highest power of the variable in the any polynomial, right? So let's take first example. So here 2x plus 4 divide by 2. If you divide this polynomial with 2, okay, so at that time a quotient you got, it always the degree of the quotient and degree of your px means your dividend are same, right? Here degree of q of x is equal to degree of r of x, means your degree of remainder and degree of quotient are same. Okay, so these are the example, try it yourself. Okay, just dividing it and verify it. The degree of q of x and degree of r of x are same. Here degree of r of x is 0. So how you say that the degree is 0? If you got a constant in remainder, so it means it is 0. So here you just divide it, okay, and you got the remainder 0. So it is also an example of a 0 degree polynomial, right? I told you that it may have a many examples, okay. This is not a only example, okay, it have a many examples. So I give you another example, right? This is another example. If you divide it, you got a degree of p of x and degree of q of x same, right? If you divide this, okay, you always got degree q of x and degree of r of x are same. And if you divide this polynomial with the 2, then you got a degree of r of x is 0, means your remainder is 0 or any constant term, right? So here I complete the chapter number 2. If you like this video, you can subscribe my channel. Thank you.